Let's solve the following system of equations. There are two examples here, A and B. We'll go ahead and do example A. The first thing I'm going to do is actually label the equation. I'm going to call the first one equation 1 and the second one equation 2. Now the first one has a nonlinear equation and a linear equation. What we're going to do is take that linear equation, which is equation 2, we're going to sub 2 into 1. The first thing though, even though I'm going to sub 2 into 1, I got to rewrite equation 2. So maybe I won't label that as equation 2. I am going to label the first one equation 1. I'm going to rewrite the second equation to be y. You can easily see that you could write y by itself. So that would be 3x plus 4. I'm going to call this equation 2. And I'm still going to sub 2 into 1. But now I'm just going to do it a little bit later. So I have equation 1, I have equation 2. Now I'm going to sub 2 into 1 because I have y by itself. So for equation 1, whenever you see y, put parentheses. X squared plus y. Well, y is going to be in parentheses and y is going to be 3x plus 4. Quantity squared is equal to 8. And now you could react to this as if it was an algebra problem, as if you have been solving quadratic equations for most of your life. So here we go. Is equal to 8. And of course, for quadratic equations, we would like to set the equation equal to 0. So let's try 10x squared plus 24x plus 8 is equal to 0. There is a greatest common factor here, so let's factor out a 2. So we get 5x squared plus 12x plus 4 is equal to 0. Now we're going to factor this. I like to use trial and check. Luckily 5 is a prime number, so we can use 5x there. Can we make 12? I believe so. Put a 2 and 2 here, and then put a plus and plus here. And I did check my factoring. That is correct. This is now equal to 0. Now 2 is a factor that's not equal to 0. However, we do get x equals negative 2 halves. I'm sorry, negative 2 fifths. Or we get what? X equals negative 2. So how do we get our y values? Well, then we go back to equation 2. So I'm going to bounce off of equation 2 here. And let's solve for y. So the first y is when, let's say, when x is equal to negative 2 fifths. Can we get y? Yeah, of course we can. That's negative 6 fifths plus 20 fifths. So y is going to be equal to 14 fifths. Let's try to get another ordered pair. How about when x equals negative 2? We're still going to use equation 2. So y is equal to 3 times negative 2 plus 4. So that is now equal to negative 2. So for example A, we have a set that consists of two solutions. We actually have a set with the ordered pair, negative 2 fifths, comma, 14 fifths. And then the second ordered pair, I'll separate it with another comma. We'll put parentheses, negative 2, comma, negative 2. Close with a set brace. I'm going to repeat this again. This is a set that consists of two solutions or two ordered pairs. I'm going to circle that as the final answer for example A. And let's proceed to example B. Now for example B, both equations are nonlinear. And you can see they're both nonlinear because there's actually a square or an exponent of 2 on your variables. So both of these are nonlinear equations. But the first column has a like term and the second column has a like term, which tells us we should actually use the addition method. I am going to do something a little bit different. I'm going to take the first equation and I'm going to multiply it by negative 1. If you do that, you get negative x squared minus y squared is equal to negative 10. So multiply both sides of the first equation by negative 1, you get that. I'm simply going to rewrite the second equation, x squared plus 5y squared is equal to 6, and now we're ready to do the addition method to our new equations 1 and 2. We get 4y squared is equal to negative 4, and we divide the entire sides by 4. We get y squared is equal to negative 1. Uh-oh. Well, guess what? We're trying to keep these solutions in the Cartesian plane, or in the real number two-dimensional system. Okay, remember your axes that you're looking at, these are in the xy plane if you were to graph these. So right now we have 4y squared is equal to negative 4. Well, that is bogus. In other words, it's not possible to get a y value here. Y is equal to a complex number, and we know that plus or minus I is not real, or not a real number. So this is not a real number. In other words, that's going to imply us to conclude no solution. Even though you got no solution, make sure you're able to show all this work. All this work is necessary.